Hi there, welcome to my channel. In this video, we are going to solve our next interview problem, which is remove nth node from the end of the list. So here we have a linked list with us, and we have to remove nth element from the end of the list. So quickly, let's create one linked list here. So we have 5 elements, and all the nodes are pointing to the next node, and this is a head. Yeah, now let's see how we are going to solve this problem. So here, if you see the problem, it is saying we have to delete element from the end. So how to get to the end, how to find out the position of the element which we have to delete. So for that, also if you notice, it's a single linked list. So we can only move one way, we can only move forward, we cannot come back. So somehow we have to identify the position. So what we can do, we can place one pointer here. We can place one pointer here, which tracks the end of the linked list. And based on that, we can place one more pointer, let's say it's Q, to this particular location, the nth location. So by using two pointer technique, we can easily solve this problem. So let's see how we can use two pointer technique for this particular problem. So first of all, the first step would be take two pointer P and Q and assign it to with a head reference. So we'll have two pointer P will be pointing here, Q will be pointing here. So Q we are going to use to track the end of the input, and P we will use to delete the node. So P we will be placing to some position from where we can delete the node. And also we have to make sure that we have to place P in such a location. Suppose if we want to delete this particular item, then we have to place P here because it's a single linked list. We can't come backward. So if we have P here, then we can easily delete this item and we can point it to the next node. So we always have to make sure we have to place it one node before the deleting node. Now let's see how we can do that. Yeah, and in order to do that, what we can do among these two pointers, we can keep a distance of n. If we maintain this distance, then when we reach at the end, means when we move q pointer to the end, and if we are maintaining the same distance, then p pointer will be at that position where from where we can delete the next node. So let's move forward. So the second is we have to move the pointers. So what will happen? P will be here now, and based on n, we'll place Q with a distance of n. After that, we'll keep incrementing P and Q till the Q reaches the end. So when we do that, let's increment it. When we do that, Q will reach here, Q will reach here, and P will be at this position. So easily we can delete this node now just by writing one statement. We can do p dot next equal to p dot next dot next. So what I'm doing here, so every linked list has two attributes with it. One is value and one is next pointer. Next pointer basically it points to the next node. So what we are doing, we are changing the pointer here. We are taking this address and we are assigning it to this address. So this node will not be referenced from anywhere, and this node will be deleted. So this is the approach we are going to implement in our program. Let's see a quick JavaScript program, how we can handle it. I'll call it remove nth node. We'll have head with us and n value. Let's quickly write our two pointer. Both will be pointing to head. And we'll write a loop. And this will go till n. And here we will be moving our Q pointer to a correct position so that the distance among P and Q is n. Yeah, so it's done. First step is done. Now let's move to the next step. So in the next step, we have to move P and Q such that Q reaches the end. So here we'll do Q dot next. So next point for the last pointer, next will always be null. Next will always be null such that it won't be pointing to anything. It's the end. And here we'll do P dot next, Q dot next. This part is also done. And at the end, we'll do P dot next equal to P dot next dot next. So we have deleted our node. Now we'll return the head. That's it. So this is done. This program is fine, but there is one corner case which we have to handle. If you see this particular input, we have only one element. So we have to handle this corner case if we have only one element in the linked list and if we have to delete it. So here, this is a head. Now let's run through this program. So if you go through this program, P will be pointing here, Q will be pointing here, and we are incrementing it. So it will be incremented by 1. We are starting with 0, then value is 1. So Q will go somewhere here, which is null. And it will come here now. And if it checks for this condition, Q dot next, Q itself is null. So the program will break here. So we have to handle this case in our program because this is insignificant for this particular case. It should not go beyond this line. We have to write some of our logic which can return our function from here itself. So there is a one line which we can add here to prevent this break. And that is, we can put a check here. If Q doesn't exist, that means if Q is null, then we still have to delete this element. So what we'll do head dot next, which is null. So here we are checking if Q doesn't exist. That means if Q itself is null, then we are returning head dot next. So it will not go beyond this line and it will return from here. So this is a simple program and this will handle all the cases now. Now let's talk about the time complexity. So if you see here, we have a for loop here. This for loop, which will run for n times. So the time complexity is order of n. And we have another while loop, which is not order of n, but it will be less than order of n. It's less than order of n. So if you combine these two, it will be equivalent to order of n. So this is the time complexity of our concept. So I hope this is clear now. In case if you have any doubt, you can ask me in the comment section below. And if you find this video useful, don't forget to like, share, and subscribe. And I'll see you in my next video. Thank you.